close to the star in order to be at this temperature. But if you put the planets very close to the star, there is a tidal pull that the star exerts on the planet, so that the planet always keeps the same face to the star, and therefore, it is said, the near side will be too hot, and the far side will be too cold, and it's inconsistent with life. Isn't it remarkable that big G has the value it does? We'll come back to this. Or consider the stability of atoms. Electron, with something like 1/1800th the mass of a proton, has precisely the same electrical charge. Precisely. If it were even a little different, the atoms would not be stable. How come the electrical charges are exactly the same? Is it so that 14 billion years later, we, who are made of atoms, would be around? If the strong nuclear force coupling constant were only a little weaker than it is, you can show that only hydrogen would be stable in the universe, and all the other atoms, which surely are required for life, we would say, would never have been made. If certain specific nuclear resonances in the nuclear physics of carbon and oxygen were a little different, then you could not build up in the interiors of red giant stars the heavier elements, and again, you would have only hydrogen and helium in the universe, and life would be impossible. How is it that everything works out so well to permit life when it's impossible to imagine quite different universes? What I'm about to say now is not an answer to the question I've just posed. It's not difficult to see teleology hiding in this sequence of arguments. And in fact, the very phrase anthropic principle is a giveaway as to at least the emotional, if not the logical underpinnings of the argument. It says something central about us. We're the anthropos. And that's the reason I'm saying that this is another ground, somewhat covert, on which the Copernican conflict is being worked out in our time. J.D. Barrow, one of the authors and promoters of the anthropic principle, is quite straightforward about it. He says that the universe is designed with the goal of generating and sustaining observers, namely us. What can we say about this? Let me make, in conclusion, a few critical remarks. First of all, in at least parts of this argument, there is a failure of the imagination. Let's take that red dwarf argument, in which if the gravitational constant were an order of magnitude less, then we would only have those red giants. Is it true that you could not have life in that situation for the reasons I mentioned? It turns out it isn't, for two different reasons. Let's look again at that tidal locking argument. Yes, for a close-in planet and the star, it seems possible that the net result would be the same kind of situation as for the moon and the Earth, namely that the secondary body makes one rotation per revolution, therefore always keeping the same face to the primary. That's why we always just see one man in the moon and not some woman in the moon on the back that we see as well. But if you look at Mercury and the Sun, you find a close-in planet, not in a 1-to-1 resonance, but it's a 3-to-2 resonance. There are many more than just this one kind of resonance that are possible. What is more, if we're talking about planets that have life, we're talking about planets with atmospheres. A planet with an atmosphere carries the heat from the illuminated to the unilluminated hemisphere and redistributes the temperature. So it's not just the hot side and the cold side. It is much more moderate than that. And then, let's take a look at the more distant planets that you might imagine were too cold to support life. This neglects what is called the greenhouse effect, the keeping in of infrared emission by the atmospheres of the planet. Let's take Neptune, at 30 astronomical units from the Sun, so you would figure that it has almost 1,000 times less sunlight. Yet, there is a place we can see with radio waves in the atmosphere of Neptune that is as warm as it is in the cozy room I'm in. happened here is that an argument has been put forward, but in insufficient detail. It has not been looked at closely enough, and I bet that will turn out to be the case in some of the other examples I present. Second possibility is that there is some new principle hitherto undiscovered, which connects various apparently unconnected aspects of the universe in the same way that natural selection